Hello, welcome to everyone to this short tutorial of Copernicus Marine Services. In this session, we are going to explain how to install RStudio in your own computer. This is a supplementary material for the Copernicus Marine Training Workshops. In this session, we are going to cover the following sections. First, we will install the RStudio development environment. And to do that, we are going to download the program from the official website, this website. And after that, we will give some first steps to work with RStudio. We will show how the environment of RStudio, and we are going to work with scripts. We learn how to install packages in the system, open netcdf files, and how to access data in netcdf files. Going directly to the contents of the course, here I have a folder that in my desktop called RStudio install, and here I have two example files. This .r file with extension .r is an R script, but by now we cannot work with these files, and we also have a netcdf file, but we cannot work with these two files because we don't have installed the R system in our computer. So to install the system in our computer, here I have the web browser where I have opened the official website of RStudio, and here you can see there are two steps to install RStudio, because RStudio doesn't have their own program interpreter, language command interpreter. First, we have to install a command interpreter in our computer, and after that we can install RStudio, which is just a integrated development environment. It has just an environment to work with the command interpreter R, right? So first of all, we have to install R by pushing this button, and this send us to the CRAN RStudio website, which is the official website of R. And from here we can select the system we are going to install. In my case it's Windows. And I am going to select the base distribution. And here you have some options to select a different version, but I am going to select the recommended version, that in this case is 4.4.0. And with this, it opens the window to download the installer, and well, I am going to download the installer in the RStudio install folder, in this folder in my desktop. Well, this shouldn't take too much time. Actually, it is done. We can go back. And here we have the installer in the folder, in the working folder. So I can run the installer by doing double click in the executable. And well, since this is a program that it is going to make changes in the system, the program asks for permission to make changes. You have to accept, and it starts the installation process of the program. First of all, you are asked for the language to be of the installation. In this case, I am going to select English. And here you have the windows of the installation process. I have to say that there is no need. This is the license of the program. You have to accept the license, and from here you get some options of installation options, but there is no need on changing anything here. So you can just accept the default options, for example, the destination of the installation. Yes. The components, default components, and startup options, default options, and here you can select, for example, if you want to create desktop shortcuts or create a quick launch shortcut, etc. I am not going to change anything. And with this, you can see it starts the installation process that maybe take 30 seconds or 1 minute. And while this is running, I am going to download the installer of RStudio by clicking here in the web browser in this second button. So there appear a window to download or to store a new file, RStudio. This is the installer of RStudio. I'm going to select the same folder than before. And here, as you can see, I have already downloaded. Here it is. But remember, you shouldn't run this second installer until the first installer has finished. Well, once the installer of the command interpreter has finished, we can close this window and we can run the installer of RStudio. Double click here and we will receive the same request of permission for changes. Here it is. We have to accept. And this starts the installation process in a new window. And here, as before, we don't need to change any option in the installation. For example, we can select all the default options, for example, the location, the name of the program in the start menu. And this installation can take few minutes. So I am going to stop the video, the recording, for a few minutes, and I will be back when the installation is finishing. Well, the installation process is finishing, as you can see here, and after that, when it finishes, we just only have to close the window. Well, we have RStudio in our computer. For example, we can search for the program in the start menu, and you can open the program from here, or I usually prefer to, when I work with R scripts like this one, I prefer to do a double click in the script, so automatically the system opens RStudio to manage this script. And here it is the normal environment of RStudio. As you can see here, there are 4 different windows. In the upper left window, we have the command lines. You can see here, this window is the script we have opened. This is a text editor of the script we have opened. And we can work with the lines of this script because we have also in the upper right window, we have a console. This is our console where we can type any R command. For example, we can create a variable called A, and we can assign a number like 8. So we can type A plus 3 equals 11, right? We can work with these windows, with the script windows on the console windows, because we can run the lines of these scripts in the console, as you can see, for example, and we can do that by passing in your keyboard the Control-Enter keys. For example, you can select this line, print.ncds, and pushing Control-Enter. Obviously, we receive an error because we haven't run the previous lines of this code. But you can try to run this line in the console. And also, you can run blocks of code. For example, selecting a number of lines. For example, here I am selecting these 3 lines, and I can push Control-Enter, and these lines will be executed But here, since we have an error in the first line, we cannot see that the second and the third line has been executed. Here we have also two other windows. Here in the bottom right panel we have a window that called plots, that anytime we create a plot with our scripts or in the console, the result of the plots will be shown in this window. Here we have also in this window also different tags. There is an interesting tag also that is files tag, that is a file browser of the working directory where you are currently. And also there is here in the bottom left panel the environment window. In this environment window there is a list of the variables you have created in the console and in your environment, in your session, right? So as you remember, we have created a variable A, and we have here the variable A that it's equal to 8, right? If we create a new variable, for example B equals to 4, there appear here the new variable and its value. Here you can also navigate through the variables and objects, etc. But I am not going to spend time on that now, because I want to focus on this example script I show you. In this script there are two main sections. Here I have a first section where we give some examples about how to manage packets in R. And here we have some code lines to show how to access netcdf datasets, right? Going to the first section of our script, here you can see that there is the declaration of a library, RNetCDF. In R, like in Python, anytime we want to, you probably know that these kind of systems work with packages that are installed in the system. So once you have installed that packages in the system, you have access to use a set of functions that are very useful for different processes, right? In our case here, since we are working with we want to open a netcdf file, we are going to try to load the RNetCDF file, RNetCDF library. But as I said before, these libraries, before being opened, must be installed in the system, right? So to install libraries in the system, there is this command, install packages RNetCDF. So before trying to open the library RNetCDF to load the library RNetCDF in this session, we have previously to install the package, right? To install the package can be done by just running this line. As before, I said before, I am going to select the line and push Control Enter in my keyboard. So as you can see here, the package is being installed in my system and it finished. And now, yes, I can run this line to load the library RNetCDF. This library, RNetCDF, is a library, very famous library in R that provides different functions to access data and open data sets of netcdf format. The netcdf format is a very common format used to store geophysical data, and actually is the format that Copernicus Marine Services uses to deliver his products. And this is because we are doing this specific example. So here, as you remember, here in the folder RStudio installed, I had an example netcdf file with extension .nc. This extension .nc is a common extension of netcdf files. And from now on, we are going to use some commands from RNetCDF library to access the information of this example netcdf file, right? To open a netcdf file, there is a function called open.nc. it's a column function that that opens a file that is included in the function, and it creates an object that is, in this case, is called DS dataset. And using this object, we can access the data of the dataset we have opened. Well, I am going to open this, or run this line by pushing Ctrl Enter, and this creates the object dataset that, as you can see here, it's a netcdf file, and this is the size of the file. And with this print function, print.nc, we can print a report of the dataset we have just opened. I'm gonna collapse it, since we don't want plots today. I am going to collapse this window. So as you can see here, the system has printed a report of the information stored in the netcdf file. Here you have. As probably you know, netcdf files contains different types of objects like dimensions, variables, and global attributes. And there is also a specific type of attributes which are the attributes of the variable attributes for specific variables. These dimensions is the declaration of the one-dimensional variables of the file that will serve to define the dimensions. For example, here, as you can see, there is declared a dimension called time, latitude, and longitude. So our file contains data sets that are defined in this grid. And to know what grid is this, there is specific variables with the same name than dimensions. For example, here we have the variable latitude, longitude, and time. And in these variables, we have the definition of the grid for these three dimensions. And there is also another type of variables that are the real variables in netcdf files. For example, here we have a variable called ADT. And looking at the different attributes of this variable, we can see that this variable is called absolute dynamic topography, and it contains sea surface high above geoid, and a comment, for example, explaining what is this variable, and also the units of the variable. We can get from attributes, we can get a lot of information, as well as from the attributes of the different variables associated to dimensions, for example, latitude, longitude, and time. Here it's interesting, later we will see that time contains an attribute called units, and this attribute units is day since 1950, right? So the units of this time variable are a number of days, are not dates actually, it's a number of dates. Right. There is also a lot of attributes, global attributes for the file that specify a lot of information. Well, sometimes they are very interesting and useful, but I'm not going to explain all these attributes now. We can see how to access the data of these variables. Well, to do that, we have in our netcdf there is another function, var.get.nc, and this function allows you to access the dataset. Access the dataset you have opened and to download the unspecific variable. Here in this example, I am downloading the variable, the information of variable ADT. As you can see, it is here. And for example, if you want to plot maps of this ADT variable, you will need also the information of latitudes and longitudes of the grid for this ADT, right? So for example, here I am downloading or getting the information of the variable latitude and longitude, right? So I am creating three new objects, var, lat, and long, and these objects contain the information of the data. I'm going to select these three lines and run it. here you can see we have run the lines, and for example, if I print bar, we can see the data in the bar. Oops, sorry. And also I can type, for example, dimensions, the var. Oops, sorry. And you can see here the size of the 3 dimensions of the array var. Here you can see that the dimensions of this array is 108, 120 and 3600. The size of this dimension should be the same size than the case of latitude and the case of longitude, and the size of the dimension time. For example, if we go back to print the report and we go to the dimension, the definition of dimensions, we can see that the latitude dimension has 120 values, and longitude, the grid in longitude contains 108 values, and time 3652 values, right? So these dimensions correspond to these dimensions, the size of these dimensions, right? Of the different dimensions in the file. Well, for example, we can also print the variable latitude that we have get from the file, and here you can see that latitude, the object latitude, is a vector that contains all the values of latitude in the grid of the file. And also we can do the same for longitude. Sorry. And we do the same for longitude, and we can see the different values of longitude where the data set has been defined. We can do the same for the time values, for the time dimension time. For example, here we are downloading or getting the information of, sorry, there is here a mistake. This is the yes, this is the yes, okay. Yes, we can get the information of the variable time using this var get nc. But if we print, as we said before, if we print time, sorry, we have different values that actually they are not real dates or the real times. Actually, this is a number of days before 1950. We can transform this into a specific dates because R contains library that is able to work with dates. So with this function, as we can, here we have a concatenation of two different functions, as date and utcall.nc. Let's explain this in parts. First of all, we have a function utcall.nc. This function corresponds to RNetCDF, and it's a function that allows you to transform these time values into strings of dates. For example, if I type this into the console, you can see that now the value of the dates has been transformed into a specific dates, but this dates has been transformed, but in format of a string. They are strings, but we usually don't want to work with dates as strings. So to do that, to transform that date objects or at date objects, we can use this ArState function that transform these strings into date objects. So first of all, we have to download to get information of time, and also we need the information of time units. As I said before, if we print the netcdf report in time, it has an attribute that it's called units that gives you the information of the units of this variable. So we have to get the information of these units in the variable time. So to get this information, we use this new function attribute get.nc that associated to the dataset in the variable time and with the name of the attribute units. And with this command, we can get the information of the units of the variable time, right? So from here, we can use the uticall variable to transform the time the time in dates, but in format of a string. And after that, we can transform these strings into date objects or date objects. So when we print this date array, we can see that this array contains dates objects. From here, well, we have learned how to access the data and how to access the attributes of any data, how to open netcdf files, and well, this is the basic knowledge you need to start working with netcdf files. And well, this is the end of this tutorial. I hope you find interesting information on this tutorial, and see you in the next one.